that recording and shrink that down. And one thing I wanted to look for is basket. Let's see if I can find an image of a basket here. Let's just go to that location here. Open file location. I know I have a basket somewhere. I just lost track of my basket. Where's the intro project? Where is it? Where is it? Where is it? Nope, not that. There we go. Lego chest. That's the one. Gotta have the right one. So, there's that. There we go. Now we can make progress. Ridiculously large Lego chest there. Okay. Did I hit record? I'll double check that. Yes, we're recording. And back to here. And today is there. So we've got a couple of different topics to discuss today. I just feel like I'm missing something. Is there something obvious I'm missing? I don't know. I guess I didn't have my earbuds in last class, and it still felt okay, but now I feel like I'm missing something. Maybe it'll come to me. So last time we had our, let's see, that's that. Discord is that. Yeah. We're good. So last time we had our enemy, our antagonist sort of moving left and right across the top of our screen for our apple picker or apple dropper, kaboom, whatever you want to call it, arcade style game. And we were instantiating apples, and they were dropping, and they were using physics. We had gravity causing them to fall, and they had rigid bodies on them, and they had colliders on them so that potentially they could hit things and interact with things, but we didn't have much in the way of real interactions going on. So let's see. Let's pull up here, see where we were. And I'm going to take this Lego chest and make it disappear for a moment. and play the game. And this is moving left and right. And nothing happens when we get across there. All right. So a few quick notes about some of the projects, some of the things that I noticed in a bunch of projects that I did not take off any points for, but I'd like to get squared away in future projects. When you are designing in game mode, and by the time you save your project or export your project, please make sure that you're in 16:9 in aspect ratio, not free aspect ratio. It gets really weird, like you can see here, if I shrink this down or I increase the size there, I'll see a game window that's adjusting based on kind of where I am or what I have my settings happen to be. At home, I happen to have a very wide 34-inch monitor, and so it creates these kind of aspect ratios which are really wide, and if you didn't set that, and maybe you were in free aspect ratio, and I'd wind up with buttons off the bottom of the screen. Typically, is resolved by just me selecting 16:9, and then it would just be okay. But do get in the habit of setting that, and I think there was only one instance where someone had not set the canvas to scale with screen size and left at constant pixel size, which led to a few artifacts, but not a big deal. But for the most part, everything was okay, and like I said, I didn't have that impact much. Overall, I was pretty happy with how things turned out. I do want to mention, and there's going to be, I have a piece of today's lecture, we're going to talk about juiciness or kind of, things that separate one game from another. So with regards to the way the points break down, most of you should have seen by now, there's sort of the 10 sort of overall project points, which I look at it and it's okay. Did it comply with the spirit of the game, and did it come through? Was there some originality to it? So 0 to 10 points for that. And then there's the feature points, and that should be all pretty straightforward. I think there were a few that if you follow tutorials sort of too well and you really just kind of come up with exactly what was in the tutorial, that kind of usually led to, I mean, it's not a major deficit, but it might have led to say a 9 out of 10 as opposed to 10 out of 10. If I don't see anything that kind of, some kind of creative spark or interpretation or something that kind of set it aside, you might lose a point for that. Or in some cases, if it's sort of you went kind of sideways with the prompt a little bit. One of the things about this particular game was it's supposed to be very much audio driven, and so if we could kind of look at your game and say, well, could I play this without the images on the screen or the graphics on the screen? Would it be completely impossible, other than obviously I'd need to know where the buttons are? But if it really kind of went left with regards to the notion of it being, relied too heavy on graphics, that might have been a point there. So there's a little bit, nothing major. I think overall everyone did fine, and it certainly, I don't think anyone is in a danger of it having a major impact on their grade overall. And certainly with the way the new system is, with the whole feature point system, I think everybody's going to be fine. But that is kind of what I'm looking in that the 0 to 10 project points, is to say, is there some creativity? Did you stay within sort of the genre, the realm, and so on? But I think we're good. I think we're in we're generally on the same page. So overall, I'm happy. I'm in a happy place. So in here, fix those two things if you didn't. Go ahead and set your aspect ratio, especially now that you may be clipping, deciding how far left and right and so on, that kind of thing. So now, let's see, we have our antagonist across the top of the screen. He's dropping the apples. We have our thing that can potentially be catching the apples. And for that, I want to swap out, let's see, we had the crook, the player. So let's go ahead and potentially, right now, the player, I'm going to put this other chest on, which is now way too big because the import settings, this is what I want to look at here real quick. Import settings 100 pixels per unit, since that's a very large image, it looks like it's quite a bit too big. So if I said 200 pixels per unit, you'll see how it should get smaller. I want it to be smaller still, so I'm going to say it's probably, say, 256. I'll go all the way to 300, right? So the larger that is, the more pixels per unit, the smaller the image is going to look on the screen. Our antagonist here, our crook, is the right scale, so he's about 1 meter high, but well, maybe that's big enough, maybe it's not. Anyway, we'll leave that. So now we have the basket on the bottom here, and we have the crook dropping apples, but nothing happens when they're potentially caught. So the idea today is to talk a lot more about specifically the interaction between objects using physics, using rigid bodies and colliders, and also ways and mechanics that are sort of built into the engine to help us streamline that process and identify what's what hit what, and so on and so forth, right? And also dropping and catching apples. Colliding apples in baskets using tags, layers, and destroy. So one of the big questions in the game as things start interacting with one another is they have to kind of figure out, well, what are you? What did I bump into? When one object bumps into another, how does it figure out what that other object is? Or potentially even, if there's a script or component that's on an object, how does that script know what type of object it's actually even on? So one simple way of doing that is this thing called tags. One approach is tags. A tag is a reference word which you can assign to one or more game objects. So you define tags in the Unity editor, and then any game object can be tagged with one of those tags. It's really just a simple string. So for example, you might define player as a tag for player-controlled characters, or an enemy tag for non-player controlled characters. So this way you might be able to define items the player can collect in a scene with maybe collectible tags or power-up tags or something like that. It's generally sort of a group kind of description. It's typically broad. You can define any number of tags you like because they're basically just strings. To figure out, is the tag on the game object, or is the game object named that, you can say, oh, okay, GameObject.compare tag to basket, or whatever it is you want to compare it to. That'll return true or false, depending on whether the game object is tagged that, right? Notice this is a small lowercase game object. Whereas now I can also look for, within the game object class, just like I could say GameObject.find things of a certain name, I can also say GameObject.find with tag and specify a tag, and it'll find me the first game object, or all game objects. Let's see, wait, no, find, where are we? Find game objects with tag, all of the things tagged by that, with that name as well. So there's a bunch of different options you have in terms of finding things or comparing things, or if you're handed an object, does it have that tag on it? Right? So for example, you could do things, I think in the text, in the original text, the prototyping, Gibson's prototyping book, they, when it came time to destroy all the apples in the scene, for example, you could use this last statement here. For each game object apple in GameObjects.find objects with tag apple, so that would give you all of the apples as instantiated in this for each. And then you can say destroy apple. So that would destroy all the things tagged apple, right? So, or, and this is not a built-in function, this connect basket to player, but maybe you go and you have some kind of template where you put a bunch of objects in the scene that are all tagged basket, and so you allowed the designer, the person editing, can place all these things. And as long as they have objects that are tagged basket, you would connect any baskets that the designer put in the scene, connect them to the player object or something like that. You can do that. We'll show an example of that later. I wouldn't call it an advanced technique, but it's an interesting technique. So it's great for grouping things, looking through things, and so on. Now, how do you use tags? How do you create tags? In the Unity editor, in the inspector window, you'll see there's a drop-down. You can only have one tag per item, per object, and you can add as many tags as you want. You want it with a list of tags, or yes, a drop-down that shows you all of the tags that have been created in this particular project, and then you decide which one you want tagged. There's also the untagged state, which means it has no tag assigned. It's just an empty tag, right? So they're useful. Searching by tags, though, can be inefficient since it might involve a lot of comparisons, right? Because it's going to go through the hierarchy in the scene, comparing potentially strings. It's probably done some hashing underneath the covers to make it a little bit more efficient. But it does involve probably doing a bit of searching through the hierarchy, so it's not necessarily the most efficient thing to do. Personally, I prefer to use them in non-time critical ways. More like if you're presented with an object and you want to find out, should I interact with that object in some way, see if it has that tag, right? So there's no searching through a whole list of tags. There's just saying, okay, does this object have that tag? So it's a one-to-one simple comparison, right? So, for example, this is another one in a non-time critical way. So like during start, you might look through everything, find me all the baskets in the scene. It's not time critical. It's not like we're not deciding as gameplay is going on, but we're deciding just during setup. Maybe you say, look for all the things in the scene called basket. You can also modify tags on the fly, right? So something that starts off as untagged or a player or whatever, you can change that. You can set tags in scripts, but the tag must already exist, right? There are other ways to add tags as part of the script and then add them to objects. So they have to exist, but you can make that existence happen in scripts as well. So you can, do potentially lots of fun things with them. So just go back to Unity quick. So up in here, it might make sense to say, all right, we've got these apples. I'm going to go into I put the Lego chest into the prefabs. I shouldn't have done that. That should have been in images. All right. But here I have the red apple prefab, and I double click on that, make sure I'm editing that one. And I might want to add a tag, and you'll see I can add a tag called dropped. Right. And then I have to make sure to go back to the object and say that, okay, now the tag is set for that to be dropped. Okay. Simple enough to set up. Now, I'd like to talk about them first. So as part of collisions, it's a nice, convenient way when you have things that are colliding and you want to say, okay, did I collide with a dropped item, for example? We have the baskets who are moving across, and they're going to have some kind of behavior in them, moving across the bottom of the screen, and then we want to say, okay, did we collide with something that we're allowed to catch? So as opposed to it bumping onto the side of the screen, which might be a collider, or bumping into something else. It might be the player wandering around, having some sort of architecture in the scene that it bumps into, and you don't want to destroy all the architecture, you just want to destroy the dropped thing which is allowed to collide with, maybe. So what are these collisions we're talking about? So collisions let us know when one game object hits another game object, right? When they start touching, basically. And not only that, but they want to have some sort of physical, quote-unquote, virtual physical interaction, right? They can't pass through each other. They should bounce off of one another. They should hit. They should collide as opposed to just touching. Touching might just be handled through a trigger If they don't, there's no physical interaction. So in the case of a collision, it's when they hit one another. Collisions typically require two related components, a collider and a rigid body. Generally, both objects need to have colliders on them, and one of them at least has to have a rigid body on it, so that the rigid body knows how to act in response to the collision. So for a collision to be registered, following needs to be true. Both game objects must have colliders, and at least one of them has to have a rigid body on it. So in our case where we had our, in our game, we had the collider, and we had a rigid body, which was dynamic, because we wanted to be using the physics system for that gravity movement. And we don't have a rigid body on the player or basket that's moving along the bottom of the screen, because we're controlling it entirely through script, and it's not really interacting, or it's not necessary for it to really interact and cause a physics response. Anything that collides with it is just going to be immediately destroyed. It's not going to bounce off. There's not going to be any kind of physical ping pong or any kind of ricochet or anything like that. So we can do this pretty simply. So let's go back to Unity, and we will just put let's get back to the scene here, hierarchy. All right. I'm going to get rid of this Lego chest. We didn't need that. Delete. We have the player, which has a chest, and we will add a component, a collider, box collider 2D. We're going to click on its editor just so we can see the bounding box that it's using here. Right. So you can see the bounding box for that. And now, when it drops an apple, we can catch the apple. And notice they will collide with one another. Right. So we catch two of them, for example. Right. Now, it's kind of interesting that you'll notice how the apples collided with one another, right? I'll probably never be able to replicate that situation again where one apple landed on top of the other apple. So you may have instances where, okay, should things collide with one another? Should apples collide with one another in addition to colliding with baskets? That we'll have to figure out, okay, how do we allow certain collisions to happen and certain collisions not to happen? Right. So for starters, let's deal with this. So we have the basket, we have the apples dropping, and we have a rigid body on the apple. We didn't need to add a rigid body because the way we're just doing a straight object position as opposed to moving a rigid body. So really, really easy. We're using that Collider 2D. Now, Collider 2D is sort of the base class. We haven't talked about inheritance much, but this is where inheritance starts to come into play. Right? We have lots of different collider types. We have box collider 2D, circle collider 2D, capsule collider 2D, all of these different collider 2D types. And they're all based on Collider 2D. So that's the base class that all of the others are based on. They have different shapes, they have certain different properties, but they come from a common base, right? So we can do things like say, they all have this commonality. It's like, are they triggers or not? The way we edit them might be slightly different, but they all have some ability to edit them. So, box collider, circle collider, polygon collider, and edge collider. I don't know why I left out capsule collider. Which one you choose is going to depend on a couple of things, not just the shape of the sprite or the shape of the visual shape of the object that you're working with, but it might also depend on how you want it to interact with other things, right? For example, if you have box colliders, they have sharp corners that tend to get caught on things, right? Whereas in the case of using players, or you have a player object that might move along a terrain or move along a tile map and things, you might use something called a capsule collider, which basically looks like a sort of a cylinder but a rounded top and rounded bottom. Looks like a capsule, like a pill capsule. And the nice thing about that is you can adjust its size, but it has a round bottom, so it doesn't tend to get caught on things. Kind of one orientation why a lot of character colliders you wind up using capsules for. So you're going to choose it based on the rough size of the image and the use of the collider as well, right? Colliders can be triggers. The difference being, if you select is trigger, it is not going to participate in the physics aspect of it, but will report when things kind of overlap, touch, stop overlapping, and so on. So in the case of our basket and our apple that's being dropped, for example, the question will be, well, do we want that to be a circle collider, a normal circle collider, or a trigger? And that's a good question. And I think I've always tended to do it using on-collision enter 2D as colliders, as opposed to doing them as triggers, which means they have an on-trigger enter 2D instead of a on-collision enter 2D event. Right. So this is where it starts to become different. Well, there's the physical interaction of it, but then there's also that each of the colliders potentially can respond to these events, these on-collision events or on-trigger events. And so here's like the two most basic ones, where you might have two colliders hit. There's the code within there. Go ahead and say whatever's in there happens. Collect it, destroy it, change the score, and so on and so on. Trigger would be the same thing, except without any bouncing off or anything like that. And the last example here is say, well, okay, imagine I had multiple things that have colliders or moving around in the world, and I want to figure out which one is which. So, for example, bumping into an enemy might have some consequence versus bumping into a friendly or neutral kind of thing. So different code should get run depending on what happens. So one of the simplest thing to do is say, well, okay, this thing I collided with, the nice thing about these collision functions, that will tell you what happened during that collision. And you can check, collision, check the game object that you collided with, not necessarily the specific collider you collided with, but the game object. And you can do things like check its tag. So in this case, all right, if this component is on the player and the player collides with an enemy, it knows to lose life, as opposed to something more mundane happening, right? So this is the use of kind of tags to help us figure out, what to do, right? So let's demonstrate, okay? Whose method should also handle the collision? That's a good question, right? If you have two colliders or two triggers, two objects that have things on them, who responds to it? Whose job is it to do what? To destroy themselves, to destroy the other one that it touched in, to add to the score? You can imagine if I had the basket and I had the apple, and I said, okay, if the apple hits the basket, add 1 to the score. But then if the basket's code says, oh, okay, if the basket gets hit by an apple, add 1 to the score. You don't want to add it in both places. So you have to decide. You have to decide, say, all right, which one should handle it? Which one should have there? And it's really anything with a collider on it, anything with a trigger on it will receive those events. It's up to you to figure out what, right? What was that? What did I hit? Check the tag. That's one of the main ways we do it. So let's kind of see that in action. All right. So in here, I have, again, I always have the choice. I have, okay, the apple that's going to be dropped, but I also have the the basket here that's on the player. So let's say, for now, I'm going to separate it out. This is one of those cases where the player controller's script, but let's add something called basket behavior. So here we have basket behavior. And for now, basket behavior, we'll just have it print out something. We'll just say we were hit. So on collision enter 2D, print we were collided by, and we'll say, whoops, collision dot game object dot tag. We'll just print out the tag of the object. Now we could have also printed out the name of the object if we wanted to. In the meantime, I'm also going to say another case. I'm going to say not just on collision enter 2D, I'm going to say on trigger enter 2D, and we're going to say we were triggered by, right? So we'll cover both situations here just to see what's what. Let's save that. And we can go to our apple here, and dropped apples have circle colliders, which are not tagged as triggers. So if we watch the console, what's going on here? Oh. What happened here? I'm forgetting the type of trying to get autocomplete to do the right thing for me. There's a slight difference in terms of, since it's not a collision. It is a collider. Notice here, a slight difference. This is the kind of thing that gets you. One, you get a collision 2D for the collision. The other one, you get a collider 2D for the collision. There is a bunch of extra information you wind up getting in here in terms of the points of contact and things like that when you're talking about collisions versus just merely intercepting a collider or a trigger sort of thing. So that's what I wanted to do. All right. That's why it's important to pay attention to the console window. All right. Oh, okay. So we were collided by, right? So we're doing okay. And then if I just come over to the same Apple prefab, and instead I set this to is trigger, the triggered by condition is being met. You'll notice I didn't change anything about the script. The script is responding to both. The interesting thing is that I could potentially have both a collider 2D. I could add another circle collider to that. One was a trigger, one that is one that's a collider. I could add a bunch of colliders to that, right? So you can even create sort of compound things. You can have, basically multiple colliders, multiple triggers on the same game object, and any of your components, any of the scripts on there, just treat them as if, any of them were hit, any of the triggers, any of the colliders, right? There are ways you can go in as you start looking at these structures here, what is the specific part of this collision, which of the particular colliders are you colliding with, which are the particular triggers, and so on. But for now, in the simple game, it's going to be, usually it'll be like one trigger or one collider per object. So we can decide kind of what to do in that case. Yeah, I guess this would be one of those cases where if I put triggers on the game on the apples, would that solve a lot of things? Like I said, it would rule out any inter-apple collisions, right? So that would be the one thing. They wouldn't collide with one another if I just made their colliders triggers, right? They wouldn't interact with the environment at all because they would just have a rigid body forcing them to fall, but then they'd have no real interactions with other things. I don't know, worth thinking about, I guess. So let's leave them as triggers for the moment, right? So let's think, what would go on here, right? Basically, the main thing that's going to happen is we may say, well, destroy collision dot game object, right? So if I want to simply destroy the game object I collided with, that would do it. So, come on. Right? So they vanish the moment we hit the basket there. So our game is getting closer and closer to being complete. All right. So we can simply check their tag to see what did you hit. In our case, I think there we didn't even check the tag because we said we can make the assumption that, well, no matter what I hit, I destroy it. You can make that assumption as well, depending on the complexity of your game. So checking tags may seem tedious. Is there anything more efficient and powerful? Well, we didn't bother checking tags in there. I wouldn't say that's more powerful or efficient other than avoiding that check in there, but it's kind of a brute force. But there is something that is more efficient and more powerful called layers, which are really, really useful when you want to control what things can collide with other things without getting into the tedious nature of, check every collision, you have switch statements or have some kind of elaborate structure where you're looking at tags and so on and so forth. And the nice thing about using layers is that it is built in so that Unity itself can control what physics layers collide with other physics layers, what can combine with what. So you can decide to put certain types of objects on their own layers or have combinations like maybe all enemies are on the enemy layer, all players or all player bullets are on the player bullet layer. So on. Layers are used throughout the Unity editor as a way to create groups of objects that share particular characteristics, not just an identifier like the tag was. So one important use is to manage collisions, but there are other uses as well, right? Particularly as we get into managing the interaction of objects that aren't necessarily part of the physics piece, but also to figure out, like as things overlap or as things interact in other ways. We'll kind of leave that. Sounds a little confusing for now, but you'll see later on. So we can use the layers and tags. They are kind of put together in that same window. I don't know why they like to be in the same window. Tags and layers. So use that layer to add or edit both of them. There are only a fixed number of layers. That's because they are contained within a 32-bit field in the object, right? So there's kind of 32 slots or 32 bits in a number, and each one of those bits corresponds to a layer, right? It gets interesting when you have all these sorts of interactions saying, oh, this layer is allowed to interact with this layer, and so on and so forth. You know, so you have like these complex interactions. So there's a finite number of those slots that you sort of have to manage. And they are managed at the project level. So that's another thing to kind of be careful of. So even if you have tons and tons of different scenes, you kind of share your layers across all of them. Now, there's probably, I haven't tried to do that in terms of ways to, yeah, there are, to manipulate the actual layer settings. You certainly could decide, all right, in this scene I'm going to use layer 14 to mean one thing that's different than in the other scene what layer 14 meant to be. But the one thing, I don't know if you could reassign the layer, this is where it comes into play, this thing called the collision matrix. And this is how you automatically can handle those sort of things, saying, okay, should player bullets interact with the player? Should enemy bullets interact with other enemies? Should apples collide with other apples? Right, basically has a matrix that determines what things can collide or interact with one another. Right? If there's a check in the matrix, that means yes, this thing can collide with other things in there. By default, they're enabled. Right? So in edit project settings, physics 2D, you get to this matrix, and it's determining what things can collide with other things. So if apples can collide with one another, there'd be a checkbox there. If apples can collide with a tree, there'd a checkbox and so on. So let's, for example, we'll look at a real simple case. So imagine we have the crook up here at the top, and we'll add a layer called enemy. And actually, we'll add another layer called dropped items. And we'll go back to crook, and we'll put it on the enemy layer. And we'll go to our apples and put apples on the dropped items layer. So in here, edit project settings, physics 2D, you'll see as of right now, enemies can hit other enemies, they can hit dropped items can hit other dropped items, everything hits everything, right? So why do we care? Why is that important? Let me give you a real example. So imagine we have the enemy up here in our scene, our crook, and let's make the enemy, because we wanted to use, somehow the enemy is going to wind up interacting with the world, so we wind up putting maybe a capsule collider 2D on it, right? So it has now a collider on there because we want to get fancy and make it so that we use collisions at the sides of the screen instead of just saying it can't move plus or minus 5. We won't change that part just yet, but so it has a collider on it. And now if I press play, let's watch carefully what happens when he drops an apple. Let's see if it happens. Okay. Nothing bad is happening because we've already fixed it by using a trigger instead of a collider, which is kind of too bad. Let's see. Let's go back and unfix that part of it. If this were a collider, not a trigger, let's watch what happens. So if you look, there's kind of a weird, it like launches it off to the side. Right? It doesn't just gracefully drop it. It actually has a little bit of a, does a little bit of a jitter and shoots it out to the side. And potentially even as it's dropping it, so there's at least one situation where it kind of bumped into it back on the way again. Right? So they're interacting with one another right now because enemies are allowed to collide with dropped items. If I were to change that and said, all right, project settings, and now, okay, enemies and dropped items do not interact. Now we'll go back to our sort of graceful dropping, doesn't shoot them out the sides. So we had two kind of ways to solve that. You know, when we can make it triggers, in which case triggers don't cause that weird physics interaction. And notice our apples are dropping and bouncing off of things because they are subject to physics. So lots of things to decide. What way do you want to do it? 6 this way, half a dozen that way. Right, notice when they were objects again, then they weren't being destroyed because they were, the destruction happens in the on collision enter, or on trigger enter, not the on collision enter. Lots of decisions. All right. So the collision matrix will help us with that. It comes a lot handier, especially as we were talking about like projectile systems where you're doing a bullet hell game or something like that, or you have lots of enemies running around and you don't want them to be all accidentally shooting one another and destroying one another, or friendly fire and things like that. That can all be resolved nicely through the use of this. All right. So typically, what are the things that happen after the collisions? Well, normally, a lot of time we're using the destroy function. Right? Destroy is used to get rid of an object or a component. Right? You can pass it a component to destroy, which will remove it from that object, or you can actually destroy a game object from within the hierarchy. Right? If it was there at the beginning and you destroy it, you stop the game, it'll be there back again at the beginning. It doesn't get rid of it, out of the game entirely, out of the persistent game. But with regards to the running game, it gets rid of it there. Now, there is a second parameter in destroy, which is a delay that says, okay, how long to wait until you destroy something. So it effectively is a sort of a lifetime, we want to say, okay, destroy this thing 2 seconds in the future, which is really quite handy when you want to create an object. Say you create a prefab, say you drop an apple, and you know that it's going to, within 5 seconds when it falls off the screen, you don't want it to last forever, right? You want these things to be temporary. Bullets are also good. Any kind of projectile that should last a fixed amount of time is a great use of this sort of thing. So being able to delay destruction has lots of useful applications to sort of let things play out before completely eliminating an object, like giving them a lifetime. But also, if as a result of them being destroyed, something else needs to happen, like maybe they have a destruction animation or a sound effect that they make. So it gets hit by something and you want to destroy it, but you want it to play its death sound or its, womp, 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 whatever sort of sound. You might say, all right, let this play out, delay the destruction for half a second, right? But you do want to be careful when you're destroying objects with a delay, because you got to remember that they will continue to potentially interact with objects in the scene, in the hierarchy, as long as they continue to exist. So sometimes you want to do things like, turn off the collider or make something invisible while all of its other embedded components continue to kind of play out if you need to. What I usually like to do in cases of explosions or sound effects or things like that, where there's something that lives on past the end of an object that's being destroyed, I like to do things like spawning explosions to be their own kind of short-lived things. So if I needed a sound effect or something like that, I would create a new instance of my splat sound and have the sound be something that lives outside of the object that gets destroyed. So that's one way around that as we get into destruction. Right. Now, I assume it's probably been at least 2 semesters now. Maybe I can take this slide out and say, well, if you're following along in the book, they liked this part where the apples would fall off the bottom of the screen and say, okay, once the dropped item, if its Y value went less than -5, it would destroy itself. So that was one way of doing it. A more effective version of that might be, say when you drop an apple, you say, okay, it's going to live at most 5 seconds, so it'll fall off. But the question is, what happens if it falls off the bottom? You need to not only figure out, destroy the apple, but also potentially you might need to destroy all the other apples and lose a basket and lose a life and so on. So maybe the simple destruction after 5 seconds might not be the way to go either. So we sort of have to figure out now, put some of those behaviors together. All right. So that's the chunk of collisions. So decisions, right? If you wanted, we could say the apples, somehow there has to be the detection of apples either crossing this boundary at the bottom here, so they either have to exceed some negative value to say they have, quote unquote, hit the ground, or you could actually put an object, a dummy object with a collider on the bottom of the screen and say, well, when I collide with that, when I enter that trigger, when something happens, that's hitting the ground. Actually put the ground there, if you like. My mask is just not behaving today. Other things you could do is you could actually use invoke to say after a certain amount of time, after it dropped, maybe it gets destroyed. But that wouldn't have quite the same feel as crossing a specific boundary and knowing, okay, now it hit, right? Because sometimes, let's see, are apples falling faster as we go on? That's another decision to be made, right? So if apples are always falling with gravity, we know that it's going to take a fixed amount of time for them to reach the bottom of the screen. That's not going to change. Gravity isn't going to change. It doesn't matter how fast we're dropping apples necessarily. They're all going to drop at the same speed. So yeah, we could use a fixed amount of time to destroy the apple, and that still would work. Decisions, right? What's the right answer? And the answer is that there is no right answer. Right? So how do you set your game apart? How do you make those decisions? When should you be choosing, do it this way, do it that way? That's the fun part, right? So I like to, juiciness is this term that it's sort of an industry term. It's sort of a game industry term. It's been used enough that I think, you hear about it after a while. It's sort of a thing. So this quote by Petro Purho, who did a presentation at one of the GDC game developer conferences, talked about juiciness, and that's what kind of spurred on this term. And the idea was that if a game is juicy, it's way more fun to interact with, and it feels more professional. Sometimes it's hard to figure out what it is that necessarily, it's the kind of the thought that was put into it, is the decisions that were made that, you can't necessarily say it entirely changes how it worked, but it has a feel. It has that interactivity. It has, the way of working that just makes sense. Some of them, I guess, so some of the things I talked about before, in the end, they might be entirely invisible, and they're just matters of programmer preference, right? How exactly you do it. You could certainly, that way it fell off the bottom of the screen and then was destroyed, or how the timing was, when exactly, what was causing it. Is it because, well, maybe we draw the ground on there and you can see it interact with it, but the sound it makes, having it make a sound when it hits the ground versus it just disappearing, That's what juiciness is, right? That's that kind of those little details that make it feel more real and interactive, right? So we're looking for that sort of thing in a game. And this is the talk, if you want to refer back to here, gdcvault.com, juice it or lose it. It's a fun one. They talk about creating just a simple sort of breakout game, and then all of the little elements that you could include that make it kind of different and interesting and engaging and kind of really immersive. And when I say immersive, I don't mean it in terms of the VR sense, but I mean kind of pulls you in and keeps you engaged, right? All those sort of decisions, those sound effects, what background music, is it appropriate, does it interact with that? What about the background graphics? Is there smooth motion? Do you use interpolation, or are things just always linear kind of motion, robotic kind of thing, as opposed to things speeding up and slowing down? If you ever watch much animation, I don't mean just anime, but anime being one thing, or any type of stop motion or hand animated things, there's always the motion that objects have is normally quite fluid, and things happen like objects don't immediately move with a certain speed. They speed up and they slow down. They lerp in and out, or they ease in and out, right? Things start moving slowly, you get up to a certain speed, and then they kind of slow down when they go to stop again. So smooth motion, interpolation, variety, changing of pace, all the nice touches in a game, right? And that's going to be up to you. Some of them may start off being driven sort of by these programmatic decisions you're making about, is it a trigger, is it physics, is it so on, does it bounce, right? You can imagine if I always use triggers, the notion of the apples bouncing off the baskets would never happen. But maybe that becomes a game thing, or maybe they bounce a little bit and then disappear. In the end, it might cause it to play exactly the same thing, but it might just look more fun or feel slightly different, right? So they don't have to be complex things. Simple things often do offer a lot of bang for the buck. And the demo that I have, I'll wait until we're done, because I have to go back and find my Unity project for that one. I did my Halloween version of the apple picker game, where sort of went off the rails and all sorts of fun different reasons. All right. So in mentioning a lot of those things in terms of look and feel and motion and all those kind of things that make a game feel right or look good, I'd like to use this as a jumping off point to talk about animation, because often you think of animation just strictly in terms of flipbook animation, or something is going to move, or Pac-Man is going to open his mouth. Does Pac-Man actually bite into things as he's moving? No, he's just animated and it goes along with it. Think about Pac-Man. How compelling would it be if it was just a circle that ran around collecting dots versus Pac-Man, chomping and making the sound and so on, right? The mechanic itself is exactly the same, whether it was just a circle collecting other circles, but the personality and all that stuff is just added by that little bit of animation, right? So animation can accomplish all sorts of things for us, right? Adding personality, but also another alternative when it comes to movement. We talked about before, scripted movement, movement driven by the input, movement driven by physics, but we can also have movement driven by animation. So you're probably familiar, when I do say animation, most people, the image that comes to people's minds is the kind of flipbook, Disney-style, animated movie, cartoon sort of thing. Lots and lots of pictures in succession. You flip through them at a rapid enough rate that they have the illusion of motion, right? The kineograph was the idea, is like this graphics that had kinetic energy to them, right? Kineograph, first name. By our terms, flipbook animation. Right? So frame-by-frame animation. And yes, we'll be talking a little bit about frame-by-frame animation. We'll be using that for certain things a lot. There's a lot of things like, classic 2D games typically use lots of kind of flipbook-style animation. But there's another kind of component or a modern piece of animation that we'll also use a lot, called keyframing, where we're not specifying every frame of animation or flipping through every image necessarily, but we're going to have certain keyframes that we're going to provide, and we're going to use the engine or some process or procedure to fill in the blanks, right? So imagine we have a bouncing ball or some type of movement, or even you can think of the Pac-Man case for the ghosts in Pac-Man, where the ghosts, unless they're interacting with Pac-Man, they have sort of a fixed route that they run. And at certain locations, they turn. That's just what they do. But in between those locations, they just are moving from one location to another location in a simple way. Right? So you can sort of think of our keyframing as having certain waypoints that we move between at some rate. Normally, it would be something that's probably some sort of interpolation that would be a mix, moving from point A to point B according to some either a linear relationship between the two, or you might have easing where it speeds up and slows down. We'll talk about that in another bit. But this notion of not necessarily specifying every increment of time, but instead certain key points and then interpolating or filling in the blanks later on. So I like to think that any good engine's animation system allows both of those things and more. You see it in most systems. Of course, think of this just within Unity. But the idea is that there should be some way to provide flipbook, sprite, typical animation, and some means to allow us to animate other things over the course of time. And by those other things, it's not even necessarily talking about images. It could be sort of like any movement at all over the course of time. Right? What if you want to move things with code? Well, we've talked about lots of moving things with code. Let me I reordered these slides, and I think that one should have wound up going before this other one. The notion here is, how do you script animation? Right? So a lot of the time we think of just, do the next thing in increments. And the question becomes, if we are interpolating, if we are filling in keyframes, if we want to go from this location to this location and we want to mix between the two, how do we do that in a script? How do we generate those in-between values? And there's something we call lerping or linear interpolation that we use to accomplish that. But I have a whole nother set of slides to talk about that one, so I'm not going to talk about that technique today. All right. Let's see here. So the third part is, well, we talked about animation. There's a whole other set of tools inside of Unity, and normally we kind of save this for projects 3 and 4, but I'm going out on a limb here and figured we'd introduce kind of the animation engine earlier, since I'm confident, based on the kind of level of most of the first projects that we had, that maybe a good chunk of people want to get into some more interesting things, and we'll kind of raise potentially the bar of features that you might have in your Apple picker as well by including animation earlier on. So that's we're going to try to see where we can go with this. Now, this particular slide deck, I like to keep it out there as a reference, because it's a good one to come back to and kind of go step by step, sort of as either as a tutorial or as a way to go back and say, well, because there's a lot of different kind of techniques and nuts and bolts as far as the animation engine goes inside of Unity, and it's best learned sort of as you get into it kind of with your hands on. Some of the simplest things are quite almost trivial to do in the animation engine, but advanced things do definitely require more hands-on, right? It's not just for sprites. It's certainly not just for sprites. Anything can be animated. Any parameter can be animated. Motion can be motion can be animated. Color of an object, fading in and out, its sound, all sorts of things can be animated. So it's quite powerful. So Unity has its own internal animation system. It used to be called Mecanum. Now it's just the animation engine. Similar to audio in certain ways, that audio, we have wave files or clips. That is the actual audio that we play, and we have an audio source that then plays them, right? So we have an audio source, we have a sound file associated with it. The audio source plays the sound file. In animations, we have these things called animation clips that are going to be information about how a specific game object should change its properties over time. Those properties may be images, right? So that would be a clip, sort of like defining what's changing. And then there are two other components that we use: the animator controller, which keeps track of when to play different clips, and it is a state machine. How many of you are familiar when I say the term state machine? Is everybody kind of? All right. So the animator, the idea behind a state machine, in this case, it uses sort of a flow chart to keep track of different states an object could be in, playing a specific clip when those states are, when you're in one of those states, right? So imagine we have a game object like the player, for example, and the player might have a number of states. One state might be running, another state might be jumping, another state might be crouching, another state might be falling, right? These are the states that the animation could be in, and we'd have an animation for each one of those, right? You can imagine what the crouching animation was, or the falling animation, the running, and so on, right? So the animator controller is specifically that state machine that allows us to move between and transition between these different states and trigger these different animations. Right? So these are two sort of data pieces. And then we have the animator component, which is the actual component that lives on the game object, because everything has to have a component, after all, to run. So we have an animator component that maintains a reference to the current animator controller, which in turn maintains references to the animation clips that that controller is using. Right? So to use animation, we have an animator controller on some game object, and then we'll probably have, we have an animator component on that game object that has a current animator controller that has a current animation or set of animation clips that it uses to figure out what's going on. Whew! Potentially a lot of stuff. And with that, you can do all sorts of things like, of course, animating any property of an object, or animating sprites. You might be using images or sprite sheets in a state machine for different animations. Or you can even use animations of various joints and skeletons and so on for animating 3D objects in seamless and kind of complex ways. So let's, now that I said lots of words, because there were lots of words there, let's go over to the engine and see potentially how terrible that's going to be, or how terrible that is to work with. So I think I had, let's see, I need a better set of animations here. So let's go to the internet. Well, let's go to the Unity Asset Store. So Unity's Asset Store, I should have introduced the Asset Store earlier. Great place for lots of stuff. Once you're signed in, it's kind of hooked up between the Asset Store online and when you're inside the Unity engine, once you have purchased or licensed assets, it'll coordinate the two of them together. So you can kind of browse the Asset Store online, say, oh, I'm interested in that, and then add that to your account, and later on you can look up. So there's lots and lots of things. You can use anything from the Asset Store that's free, that is not, that doesn't have scripts in. So for this course, I don't like anyone using scripts from the Asset Store. But if you want to find animations and so on, that's sort of fine. So let's go to animations. And let's look, oh, these are 3D animations, don't want to go there. Instead, let's go to 2D. And we can look for, say, characters. And usually there's lots and lots of different type of things. But we're going to also look for free assets, not nearly as many assets. You'll see there's a bunch of different things in here that I love to refer to. These one person named Ensimus, does the Sunnyland Great Asset Pack. It's a tiny RPG. I'm a big fan of his, and bunches of other ones as well. But if you grab any of I think Sunnyland is a good one, or Sunnyland Forest, they have some animations in there. This is another good one, the astronaut. Lots and lots of different ones, but I guess I'll just, once you've purchased things in here, you just select one, and let's see, I'll go through the whole process for us here. If I click on this guy, bring me to that page, I'm going to say, all right, I'm interested in this, add it to my assets, accept. Congratulations, I've got there. Now I could say open in Unity. I think it'll, is it going to open a new instance? No, it's going to try to import it right in, right? So it uses the package manager, which used to be just Unity packages things like the collaboration piece or some of the 2D, 3D engine parts and so on. But now the whole asset store is also managed through the package manager. So we have the 2D character astronaut here, and I'm going to go ahead and download that. It's pretty quick. And you say import. So it's going to import it into my current project, and it'll ask me for what things do I want to import here. I'm not going to import the animations. I just want to import the images. Let's see. The sprites. Right? So I'm going to leave out the demo scenes. I'm going to leave out the prefabs. I'm even going to leave out the tile maps. Do it the brute force way. I just want these. Import. Hopefully these work out. Either that or I spent a bunch of time importing for no good reason. And don't let me down. All right. Sure, if we take a momentary break there while we're doing that, and I'm going to take my microphone off and leave it here. I'm just going to run outside. If anyone else needs to take a break, get a breath of air, we'll be right back. So use this time to grab an asset pack that has hopefully some animations. Right. Okay. Have we all seen at least like one Zoom call where somebody wound up like bringing their mic to the bathroom or something, flushing the toilet? Okay. Everyone on Discord still with us? Is that a yes? I didn't hear anything. Nervous.
Yeah.
Okay, good, good. All right, so I'm going to go ahead and close this now, and you'll see it's probably generated. Yep, copy, sprite, sprites, and I now have a bunch of character sprites, and he has a duck motion. Let's see. I was hoping for one where he just has a typical kind of walk. Sword, slide, run, jump, idle, hold, hammer, duck, crawl, carry. Run. All right. Maybe there's walk in there, and I just done. There's walk. The very last one, of course. All right. So, just like all the other sprites that could be images or whatever, this one happens to be already kind of sliced up. Somebody has already gone to the trouble. Within this one image, it's already been kind of pre-sliced into a bunch of different sprites down here. And I'm going to look for the ones that are sort of all kind of walk to the left or walk to the right. So it looks like I've got, sort of a walk. He kind of floats in that, right? So sometimes creating an animation is as simple as, say, grabbing a bunch of sprites, right? So this is my walk cycle. And I'm going to drag this into my scene. So I just grab that, drag it into my scene, and it automatically senses that, you must want to create an animation because you have a bunch of sprites. Sprite animation. Got it. All right, piece of cake. So it's going to then prompt us for information about the animation. So I'm going to create an asset folder. In the asset folder, I'm going to say sprite anims, and I'll make that where it starts. And this is going to be, this particular animation is going to be walk. So save that. And you'll notice it automatically has created for me, if I look in assets, sprite anims, it's created a controller and a clip. Right, so it created those two things, the controller and a clip. And it has put an animator component on a object here for me, which looks an awful lot like a typical sprite. It has a sprite renderer, a default material to draw a sprite, but it has this additional animator. Now, the moment I hit play, it is going to do the right thing. And you'll see it has that nice little walk to it, right? Automatically created the animation, put it in the right place, and so on and so on. Right? So I could have decided, like, say I take this animator and I copy that component and I put it over on the crook here. Can I do that? Yeah. Paste component as new, and You'll notice it still has that sprite there, but the moment I press play, it turns it into the other guy. So we can even get rid of this one here. A little bit of a non-traditional way of doing it, but normally I just bring it in and go ahead and use that one. But since I already have the left and right motion going on over there, well, I figured why not, right? So I have the script. So now it's sort of doing the right thing left and right. I may want to tweak this a little bit to have somehow the position is all wrong, and that's probably because the center of the sprite is a little bit off compared to this guy here. So just to make it a little bit easier to work with, I'll go this one extra step and I'll say, all right, let me grab one of those walk 14, and I'm going to put walk 14 on that so I can see, okay, that's when he's up and off there. So let's just move down there. So now we have a simple animated enemy walking left and right. So this is the no code at all, simple one animation version of animation. So let's look at where's that state machine I mentioned, that kind of stuff. We should see where that is. So if I go to the animator and I double click on the controller, it shows me the controllers here. I'll double click on that. Oh, maybe I'll go to a window here. Window, animation, animator. Where are we here? Oh, sorry. It's just because this game window is too big. So this is our animator window here, and our animator state or animator state machine really just has one state called walk in it, right? That one clip. So within the animator window, there's one clip called walk, and there are these three special boxes. Get that one over here. One called entry, which means, okay, when this animation starts, we want to go into the animator. It starts at this state and transitions to something. In this case, we have one transition, the default transition to this walk state. And we could also say, well, what happens if this animation exits? And also, as we get into creating our actual animation flow and have multiple transitions and states and things, we might have complex transitions that go from any state to any other state, or kind of different really crazy combinations. But for now, we'll just stick with this one simple walk state, right? So we have kind of the most basic animation. All right. And plenty of games, plenty of people limited their animations to just about that. You can imagine, this certainly creates a little bit more excitement than a static thing just walking back and forth. I alluded to the ability to change other things, though, like parameters and properties and so on, and specifically I mentioned another way to do movement. So let's look at that. How would I change the movement of this object through an animation or another, create yet another animation? And we'll go back to the scene. I don't know if I can drag that just into the scene, can I? No, I can't. I'd have to create another object, create another sprite, put that on there. So let's actually go to our scene, and I'm going to bring another character in our fox here. We'll put the fox there. And the fox, I don't want to animate the fox's sprite. I want to animate the fox's motion. So in this case, we're going to do things a little bit more by hand. So let's name the fox fox. And we'll say that we want to go to the animation window. Right, so I called up the animation window now. Notice the fox doesn't have any animator or animator controller or anything like that. I can open up the animation window at any time, and it's warning me saying, well, I've selected the object that's called fox, but if you want to start animating the fox, I need to create an animator controller and animation clip so I can work with it. And the nice thing is that it will just create it for me, right? So this is my way of saying, well, it's not creating all these things, managing all these things isn't quite as scary as that, so it'll automatically do a lot for us. So it wants to create a new animation clip. I'll call this one Fox Move, and I'll put it in our, well, I'll put it in our sprite anims folder. So let's save it there. And now my fox has a fox controller, and if I double click on that, I can see, yes, there's a fox move animation clip, which is down here in this window. Right? This is an actual clip. There's nothing actually on the clip, though. There's nothing that's animated. So if I press play, nothing happens. I haven't animated anything yet. So what I want to do is I want to add something to animate. So I can say, I can add something to animate in a number of different ways. I could, one of the simplest things to do is kind of record what I'm going to animate. Right? So see this red button up here, which is this record button, enable, disable keyframe recording mode. Right? So I can, this is my timeline down here. I'm going to say go to frame 0 on my timeline and enable this, and now it's in enabled mode. And the fox here, I'm going to move the fox. So let's go to the scene, and I'm going to put the fox over here. And then I'm going to move this keyframe over there, and I'm going to move the fox over to there. And let's stop that. All right, so I'm out of recording mode now. And I hit play. So now you'll see the fox kind of running across the screen rapidly. And if I click the fox and enable that window, you can see the extent of my animations. Every second it is going from, now with this drop down, I can see what is being animated, the position. So my position starts off at -8, 2, and then as it moves, it winds up at 7.76, and then eventually, then it just snaps back to the beginning. Now I could do something like say, well, okay, a second later, say I wanted to bounce back and forth, I could do, all right, 1 second later puts me at 120, right? This is samples, is my samples per second. So I went from 0 to 60, that's 1 second. And now 60 to 120, that's the next second. And I will now say, well, let me enable recording again and put them back over there. So now if I press play, I've got my little sprite moving back and forth, and I can fine tune that even. I could say, let's go to the Fox animator, and you know what? I'm not really interested in, oh, I guess I can't do that. I don't want the Y position to be changing. So I'm going to say, okay, Y should be at 2, and I get to here. Can I choose that? Oh, I guess I can click that one. That's weird. I think I can click that and say, yeah. So I've deleted the Y change here. Let me delete that one. Delete. Delete. And I can even delete the Z as well, because I don't want Z to change. So delete. Delete. I can also choose them. And delete. So wherever my Fox is, I'm going to put them down at the bottom. Oh, it's at 0. What happened there? Lost track of my, did it specifically say that? Well, let's start him at 2. So we want to keep him at, say, 2. And now I'll stay at 2. So you can imagine if I wanted to, I could have used this motion instead of having my motion back and forth. The trick is then, well, how do I make it slow up, or speed up or slow down, or how do I decide randomly to change and so on? So that'd be yet another decision to be made. What is the appropriate way to do the motion? So it's another way of doing it. And like I mentioned, anything is subject to this sort of animation. So you'll see here is position, but I could add any other property, things of the sprite renderer, what materials it uses, is it changing its size, is it growing as it moves across the screen, and so on and so on and so on and so on, right? Lots and lots of things, even to the point of triggering code at specific points while it's animating. When it hits the end, okay, have an event that is calling this bit of code, or my own custom functions and things. So the animation system can get quite elaborate. And this is just the two basic parts of it: animating parameters or properties, and animating sprites. So we wanted to kind of introduce those early. All right. So those are the things we could potentially be animating. And this is when this particular slide deck comes in really useful just as a reference to remember, like, okay, when you want to animate properties, some examples, as an alternative, changing objects via code. And if you want to go through step by step, open an animation window if needed, select the object you want to animate. You can use the record preview button and then set your keyframes and so on. You can edit, like I was editing, using samples to control the rate, the location. I was using what's called the dope sheet. So actually I should have mentioned that. The dope sheet here, where it's setting a specific event or a specific key at that location. But you can also see we have the dope sheet here and the curves. It just toggles between the two. So I've effectively set, here's where it's going from one side, the -8, to the +8, and back again. If I wanted, I could even like tweak this. And you can see it's easing in and out. Like it starts off slow, speeds up. I'm going to make it kind of change its rate as it hits that other side. Or you can go even further and say, let's undo that. And change the type of curves to be linear, or even just instantaneous. Right, so there's no interpolation in between. It's either at this location or is it that location. We'll go back. Decide, does he come like in and then ease back out? If he comes in like real hard, hits that point, and then eases. Very elaborate. All right. So use the curves to fine-tune how the interpolation is going on. Use the dope sheet to set the keyframes. Reference on the state machine. Control the different states. Right now we just have a single state. We'll get into elaborate states as we do project 3 and 4. The entry state is the state the object first begins at on start and immediately transitions from the entry to the default transition there. Any state is a shortcut for when you're using multiple transitions and you want to go to a certain state from any number of other states. Exit state, when you exit animation, go back to the start, and so on. There are even the ability to nested state machines. So you can have state machines within state machines, sub-state machines, if you have like a more complex interaction or a complex action that you want to use over and again, and move from, certain behaviors like, okay, if the enemy or if the behavior is scared, that might go from, might have a certain state of substates, the scared, cowering to fearful to whatever you can imagine, come up with a case there. The transitions, you can define when and how it goes between the two states. What causes the state transition to change? So you can do things like automatically say, well, okay, if the player is moving at a certain speed, if the speed of a certain rigid body exceeds a certain amount, go from the walk state to the run state. Right. And it'll say, okay, how do we transition? Do we smoothly interpolate between the states, or do we just jump from one state to the other? That sort of thing. Right. There's also ways, just like we could play audio clips, say, okay, trigger a sound as a result of something. You can also trigger animations directly by setting play, or more usually is that you're specifying information that's going to influence what state the controller is in, as opposed to just play a certain animation. So you might be saying, well, okay, there's some sort of parameter. It could be a Boolean, could be a float, could be an integer, whatever sort of value you're interested in, where it might be the speed of the character. So you might have a float that varies from 0 to 10, and we just need to set up that parameter for the animator to know about, to know should it speed up, should it slow down, and so on. And what I'm going to do is leave the rest of this. We're going to come back to this in a bit. I don't want to get too deep in here. It's sort of like once you get to the point of having your basic game, your apple picker going, some of this won't apply just yet, because there are only fixed angles and things that are going to happen. The number of iterations. We'll come back to this probably after we're done with the first project. So just introduce the basics of this, and you can refer back to this one. All right. So let's think about this again now. So we have the antagonist, we have the basket, we have the apples that are dropping. We're going to go ahead and turn the fox off again here and come back to this. So one of the things that you're going to want to do is the requirement that there be some number of baskets. We have some number of lives. And the traditional approach to this, and I'll ask you to kind of stick with this one unless you come up with something really elaborate, just having a simple number, 3 lives left, that's no juice to that one. But the idea is that you'd have some number of baskets based on you start off 3 baskets, and then you lose a life, you lose a basket. So you'd have the baskets sort of, you can imagine, the typical thing would be that you'd have, 3 baskets. Right? So I just cut and paste the baskets. And lo and behold, because the same script is on those baskets, it's all good. I can even still kind of swipe left or right, pardon the pun, and catch the apple with those baskets. So I could just place them, the same script is on them, they all follow the mouse, everything is all good. Not the most efficient way to doing it, and also, like, well, how would I manage losing a basket? Well, I guess if I just interact with it, if there's a collision that occurs with that particular basket, I would, well, somewhere I'd talk to the score for the player. I don't know where the player's scoring script would be. How do I figure out which basket to destroy if the player misses? Well, to figure out something. So what I like to recommend, just to make it a little bit more interesting, a little more controllable, tunable, and so on, is that the baskets themselves, that there only be a single player, but there be multiple baskets that are part of the player or sit on the player as part of its hierarchy. Right? So we have the player here, and what I'm going to do is, we'll leave our animations for a bit. We'll go to our apple picker prefabs, and I'm going to take one of these, and I'm going to strip it down just a bit. I'm going to leave the basket. No, I'm going to take, let's see, this basket behavior. Yeah, basket behavior doesn't have the movement on it. It just has what happens when you collide with it, which is good. That makes sense. The player controller script is the part should be on the player here. Right? So take one of these baskets and we'll remove the player controller script. All right. And let's just call this a basket. All right. So it has the basket controller, it has a collider, just normal stuff. And I'm going to set it to 0, 0. So it has just no offset, no location, just there in the middle of the scene. And I'm going to drag that into my prefabs and make that a basket prefab. Right. And I'm going to get rid of this basket in the scene here. I'm going to delete that. I'm going to delete this one. And I'm going to go up to the player, and I'm going to go so far as to remove the basket behavior, remove the sprite renderer, and remove the box collider. So that the player controller, the player object is just a empty object with the controller's script on it. So if the game runs, and certainly that object moves, but it doesn't have anything on it, I can't catch anything with it or anything like that. But I can decide to say, well, put this as a child of, and this would still be sort of a brute force way to do it. I could put, say, multiple baskets that are children of the player. So now, whenever the player moves, I'll just do it like this, that we have a hierarchy. The player holds baskets, right? In the real world, that would be like we have the player, and the player would be holding some number of baskets. They might, and each of those baskets have a certain behavior. Maybe you get certain point values for catching it in this basket versus catching it in that basket. You know, maybe you have a basket for catching the radioactive apples and a basket for catching the normal apples. So turn your game into a sorting game. Oh, there's a juicy version. I haven't seen that version yet, where you have multiple baskets that you have to catch certain things in. We could set it up easy enough where we'd say, all right, we'll just put them, grab one of the baskets, and we'll position them side by side. All right, so now you'll have to catch in one or the other, and the behavior will be different depending on which one, right? Maybe an idea. Now we're still doing it. We still did it sort of the brute force way by saying, all right, we drag them into the hierarchy. We didn't actually use instantiate like we did with our apples. So the classic way, the book used to suggest, and you can do it this way, or depending on how fancy you want to get, is to say, well, that the player controller script here, that's where the management of baskets should happen, right? The player should decide, as the player starts up, how many baskets am I going to hold? Can I have 3 baskets? Can I have a total of 5 baskets? What happens when I run out of baskets? Where's my score? So the player is the thing that really has the state with regards to that particular player, and then also potentially how that player interacts with baskets, allocates baskets, loses baskets, wins baskets, and so on. So you can imagine during the start here, we might say, have a for loop that populates our array with the first 3 baskets and leaves 2 baskets empty for gaining additional baskets as a bonus to once they achieve a certain score, something like that. So somewhere you would need to declare an array of baskets, sort of the typical exercise. Declare an array of maximum size, and then populate from top to bottom to top, however you want them to use the offset. As if you do a for loop iterating over I, you can use an offset between the two, and so on and so on. Kind of position them. And the next thing, of course, if you have a score in here, then each of the baskets needs to know when I am collided with, when I catch something that is good, talk back to the player and say, okay, inform the player, I caught one, and so on, right? So that gets us pretty close to the end. Any questions on that? Does everyone have a pretty good idea in their heads, like where they want to run with this, right? So we have a player that has the player's resources, its baskets. We have the enemy that moves across the top that instantiates these things that we have to deal with. Maybe they're good, maybe they're bad, maybe they're animated, maybe they're not. We can use some simple animations to make the enemy more interesting. Maybe the enemy plays different animations as it moves faster as the game. I've seen ones with the haunted woods, and suddenly the one of the better ones was every so often the enemy at the top would get angry and play a certain animation, and you could see that happening, and meant that, okay, it's going to drop some special attack, right? With the classic boss battle, right? There's always the boss does something to telegraph something amazing is about to happen. So usually that would be like some special animation gets played, and then when that animation is done, it sets the attack, sort of thing. So if you feel like really going for it, try to give your enemy some extra character to it. You can do all sorts of things like, animate the apples as they drop, or if they're bombs, they could have fuses that, get used up after a certain amount of time, or whatever you want to do. You can get pretty creative with this, even with the simple follow the rules of at least have the good things you have to catch, and if you miss them, you lose, right? So that should give plenty of food for thought, and I'll stop there. Today, for some reason, I don't know, it's the humidity or the lack of humidity, my mask or whatever. I need to catch a breath. If there's no questions, if you haven't got if you didn't get a grade for the exam, not the exam, the project, we'll try to figure out it may be necessary to create another version. If you ever need to create a new version of your project, one of the simplest things to do in general is you can create a new project and use the export package to say, well, okay, let me just export everything from my game, open up a new game, import everything from that package. So the package export import is a great way to do that without upsetting the whole Unity online backup, collaborate, all that sort of stuff. So some of you maybe 2 of you might need to do that. Better now than after project 3 and 4 are done. Right. Okay, thanks everybody. I'll stop it there.